taught section 9.8 today. This is the last section in the last chapter where we're actually dealing with algebra. So we'll have a test on this later, and then we're going to move on to new things. Section 9.8, you can look it up in your book and write down what your homework is going to be, okay? It is also on Renwood. So it's going to be problems 1 through 12 on pages 385 and 386. And problems 1 through 8 really are really easy. So it's just the problems from 9 to 12 that are going to be a little bit more work. Okay, so this is work problems. It's a combination of stuff we've done before. We're going to be dealing with rational numbers, and we're going to be dealing with word problems. This happens pretty much at the end of every chapter. We cover a bunch of stuff, and then we put it into word problems. Okay, but the idea behind this is we're going to get given an amount of work that has to get done, and we're going to get given the rate at which two different machines, two different people get the work done, and we have to figure out at what rate they do it together. So there's only 2 examples. We're going to go over both examples. Example 1 is on page 384. Example 2 is on page 385. So example 1 says, a large water tank can be filled in 8 hours of continuous pumping with pump A. So we're going to write down everything we know, and then we'll figure out what we want to use, okay? So pump A takes 8 hours. But then it says if a smaller pump B works with pump A, it takes only 6 hours. So if you have both of them, it takes only 6 hours. Now what they want to know is how long would it take if you had only pump B? So we're going to make a little table, and we're going to put all the information we have. So this is pump A, this is going to be pump B, and then we're going to put A plus B, okay? Now we're going to put total hours, and I think all these problems are going to be in terms of time, but if they're not, you're going to have one column where it's total whatever, total hours, total calories, total people, total whatever is going to go in one. And then here you're going to have work per hour. So again, if the problem doesn't work, if it's not in terms of time, it could be work per people, work per calories. So just there's a total and then there's a work per however many you can do of that unit that you're using. We're going to fill in everything we have, and for everything we don't have, we're going to put a variable. So for pump A, we know that it takes 8 hours to do the entire job. So if it takes 8 hours to do the whole job, how much work are they doing every hour? 1/8 of the work, right? Because it's just 1 divided by your total. Now pump B, we don't know, right? We don't know how many total hours it's going to take. That's what we're trying to figure out. And then we have to figure out how much work it does every hour. Again, we don't know because we don't know how long it takes. So it's just 1/x. Pumps A plus B is the other piece of information they gave us. It takes a total of 6 hours. How much work does it do every hour? 1/6 of the work. So what are we trying to find? We're trying to find x. Now the information that we're going to use is of course going to be the fractions, because it would be way too easy to use the whole numbers, right? So we're going to use this column over here. Now we know that what pump A does plus what pump B does is going to equal what they do together, right? There's a plus sign right there. So all we're going to do is add fractions together. So we're going to get 1/8 plus 1/x equals 1/6. So we're going to try this method that Felicity, we're going to say, invented. And we're going to put the x on this side, find the lowest common denominator, then do some cross multiplying. So just watch. I'm just going to rewrite this. I'm going to bring this to here and this to here, so that I have 1/8 plus 1/6 equals 1/x. So now we have to find the lowest common denominator. What we have to do, it's really the lowest common number that can be divided by both of these. The easiest way to do it is to divide this into all its factors. This is 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8. 6 is 2 times 3. So anything that's repeated only gets counted once, which means that 2 is going to get counted 1 time. And then we also have to bring down this 2, and this 3. So our lowest common denominator is going to be one of the 2's plus this 2 plus this 2 plus this 3. So 2 times 2 times 2 times 3. What does that equal, Alicia? What's 2 times 2?
4.
Times 2? 8. Times 3?
24.
So 24 is our lowest common denominator. You could also say, okay, what's 8 times 2? 16. Does 16 go into 6? No. So what's 8 times 3? 24. Sorry, does 6 go into 16? Does 6 go into 24? Yes. So right there, you know you have that's your lowest common multiple. But this is the mathematical way to do it. So we know that both of these guys are going to have to go over 24. Let's deal with them separately. I'm going to bring the 1/8 up here, 1 over 6 there. So to get this guy to 24, I have to multiply it by 3, which means I have to multiply the 3 on the top also, because otherwise I'm multiplying it times 1/3, which is changing the value of the number. But 3 over 3 is 1, so that's not changing the value. So we're going to get 3 over 24. Now we're going to do the same thing for here. How do I get 6 to 24? I have to multiply it by 4. And again, to not change the actual value, I'm going to multiply times 4 over 4. So I'm going to end up with 4 over 24. Now I have two numbers that are over 24, which means I can add them together. So 3 over 24 plus 4 over 24 is 7 over 24. Now let's make sure that's what the book got. Well, they're doing it differently, so hopefully it'll all work out. So that's 7 over 24. Now on this side, we have 1 over x. So we're going to say 7 over 24, which is these two added together, equals 1 over x. Things are getting a different number than us, but let's see what happens. Oh, sorry, I was supposed to do minus. Again, nobody was here to fix me. So it's actually 3 over 24 minus 4 over 24, so that equals negative 1 over 24. So we have negative 1 over 24 equals, the 1 over x was negative. Negative 1 over x. So we actually don't even have to do any cross multiplying here, because look, you have a negative 1 on the top on both sides, so you can just say 24 equals x. If that wasn't the case, you'd have to do some cross multiplying to get rid of it, but they made this one easy for us. So this is how long it would take pump B to do the work by itself. So that is your answer, because that is the question. Now, if I had said, how much of the work does pump B do per hour? Well, then you just plug the x there and it would be 1 over 24. Okay? So that's your answer to that one. I'm going to erase this one. Again, Chris, if you have not written it down, you can rewind or you can pause. And we'll do example 2, and then you guys can get going on your homework. Okay, so example 2 says, Teresa and John are going to work together to paint their living room. Now it says John can paint it in 8 hours. So John, 8 hours. And then it says Teresa can paint the room in 10 hours. How about John plus Teresa working together? That's going to be X hours. Okay? So the table is going to be the same setup, except we have different information this time. So we're going to make our rows. You always have 3 rows if you have 2 machines working together, because you have one machine, the other machine, or both of them together. We're calling the people machines in this case. So total hours, and then work per hour. So we're going to have just Teresa, just John, and then Teresa plus John. So what information do we have about Teresa? She can get the work done in 10 hours. So how much does she get done every hour? 1/10 of the work. John can get the work done in 8 hours. How much does he get done in an hour? 1/8 of the work. Both of them, we have no information this time. That's what we're trying to figure out. And in an hour, both of them together will do 1/x of the work. So we're going to set it up exactly like we did last time. We're going to say this plus this is going to equal this. We did the same thing when we were doing distances before and principles and interest and all that stuff. The setup is very similar. So we're going to say 1/10 plus 1/8 equals 1/x. Oops. So now we have to do the lowest common denominator again. Again, we're going to take 10 into all its factors. Well, really, there's just 2 and 5. 8, we just did, we remember, is 2 times 2 times 2. So we only have to put the first 2 one time, but then we got to add 5, this 2, and this 2. So your lowest common denominator is actually going to be 2 times 5 times 2 times 2. Alicia, what's 2 times 5?
10,
Times 2
20,
times 2?
40.
40. So again, 40 is our lowest common denominator. And we did that the mathematical way. But you also have the choice of saying, okay, 8 doesn't go into 10. Let's double 10. 20. Does 8 go into 20? No. Let's triple 10. Does 8 go into 30? No. Let's quadruple 10. 40. Does 8 go into 40? Yes. That's our lowest common denominator. So there's 2 ways to do that. This is the mathematical way. If you have 3 different denominators, or if they get big, doing the whole testing one by one is going to take a long time. So remember how to do it this way, but if you forget, just look for something that both numbers go into. So now we're going to put all the fractions over 40 so we can add them together. So let's do 1/10 is the same as 1/10 times 4/4, because that's 1, right? That's going to put us at 4/40. Now we have to deal with 1/8. 8 has to get multiplied by 5. So we're going to say times 5/5. So we're going to get 5/40. Now we have 2 numbers that can get added together. So we're going to say 4/40 plus 5/40, which is the same as this. That's 9/40 equals, then we have 1/x. So remember in the last problem I said we were really lucky because we had a 1 in the numerator for both. In this case we don't. However, we can still solve this, and now we will put into use Felicity's method. So you get 9/40 equals 1/x. So I want to get rid of the x in the denominator. That means I have to multiply both sides by x, right? So then I get 9x/40 equals 1. Now I want to get rid of this denominator. So I just times both sides by 40. So I get 40 times 9, which is 360x, equals 40. Now what do I do? Sorry, divide by 360. Now I want to leave the x by itself. So I want to divide both sides by 360. Those cancel out, you get x. You don't have to do 40 divided by 360, but we can simplify it, right? Both of them can get divided by, let's start with 10. You end up with 4/36. Now what number goes into both 4 and 36? I'm pretty sure 4 goes into both 4 and 36. So you get 1, and then 36 divided by 4 is 9. So in the book it's, I divided wrong somewhere here. Hold on, guys. We got 9/40 equals 1/x. 9x/40 equals 1. Oh, sorry. Right here. If I times both sides by 40, what I'm doing here is crossing out the 40, right? So we actually get 9x equals 40. Then we say x equals 40/9, because I divide both sides by 9. And you can leave it as 40/9, or you can reduce it because it's a mixed number, so it's actually 40 divided by 9, you get 4, and you have remainder 4. And you can put that on the calculator, but you can just say 40 over 9, it's the same thing. So 40 over 9 is our x, which means that's how many hours it's going to take. So if you really wanted to give me a nice answer, you turn that into a whole number, and then you'd probably try to turn that into some minutes, right? So 4 hours, and then how many minutes is 4 over 9? Well, we do 4 over 9 times 60, and again, I don't have my calculator, so 4 times 60 is 240 over 9, which is 9 times 5 is 45, 9 times 4 is 36, 9 times 3 is 27, so it's 2 and something. So it's a little under 4.5 hours. Less than 4 hours and a half. But you can just give your answer as 40 over 9 hours. Now if they say how many minutes does it take, you'd have to convert it into minutes, but otherwise you can just leave it as that. Okay, so your problems 1 through 4 are really easy because you're not even combining people. That should take you 10 minutes. And then 4 through 8 are basically problems just like this. And then 9 through 12 are word problems. So in 4 through 8, they don't even give you the word problems, they give you basically the information to make this table. Then in 9 through 12, you get a word problem, you're gonna make some tables like this and give me the answer. Okay, that's it. That's all of chapter 9. We will take a test on it.